Hello, everybody, and welcome to my class. Okay, so today we'll be talking about seventh grade mathematics counting techniques number one, and I'm hoping to have a second class on this. And counting techniques will be very useful in later in real life. So I'll introduce the schedule first. So first, I'm going to introduce you to counting techniques like permutations, combinations, introduce some formulas. Then I'm going to give you some counting methods, okay? And then we're going to be solving some problems using those methods. Okay, so can everybody see my screen? No questions so far about the schedule. Can everybody see my screen? Okay, can everybody see my screen? Okay, yes. No questions? Then I will begin. So first, let me start with a introduction. Okay. So first, I'm going to introduce what a factorial is. So basically, a factorial is the product of a specific positive integer and all the integers below it that are above 1 and including 1. So, and we will use factorial a lot during when we're solving problems. So everybody get out your notebooks if you haven't already, and please take notes on this because you might forget. And this is extremely important. So these introductions, okay? Please take notes on every one of these slides and it will be very helpful. Okay, so factorial, as I said, is the product of a specific positive integer and all the integers below it that are above 1 and including 1. Okay, so let's say 4 factorial. Okay, we start with our 4, right? That's our specific integer. Okay, 4 is right here. Okay, and then we multiply it by all the integers below it that are above 1 and including 1. Okay, we multiply by 3, 2, and 1. Okay, once you get to 1, stop, because if you multiply by 0, it's always going to be 0. So there's no point in doing that. So once you get to 1, stop. Okay, and 4 factorial equals 24. 1 times 2 times 3 times 4 equals 24. So let's do another one. 5 factorial would equal, okay, 5. Okay, that's our specific positive integer times 4 times 3 times 2 times 1. That equals 120. So like 4 factorial, 5 factorial, it's great if you memorize those. 1 factorial is 1, of course. 2 factorial is 1 times 2, which is 2. 3 factorial is 1 times 2 times 3, which is 6. 4 factorial is 24, and 5 factorial is 120. You can even memorize up to 6 factorial, which is 720. Okay? So it'd be great if you memorize these small factorials. It's very useful. You don't always have to go to your calculator to solve for some factorials. Okay, so now that I've explained what factorial is, I'm going to introduce a brief, a broad formula, okay, for factorial. So n factorial, and n is a variable, and n symbolizes, okay, n denotes any specific positive integer. In this case, in 4 factorial, 4 is n, right? 4 is the specific positive integer you're trying to factorial. Okay, so n factorial equals n itself times n minus 1 times n minus 2 all the way to like n minus 3, and then once you get down to 1, okay, you stop. Okay, and that's what we just did, right? So for example, 6 factorial. In this case, 6 is our n right here, okay? 6 is our n, okay? Multiplied by 6 minus 1, 5, right? Multiplied by n minus 2, which is 6 minus 2, which is 4, right? So you see, we kind of go down the line right here. We multiply all the way, okay, to 1. which is 6 minus 5. Okay, and then we get 6 factorial equals 720, right? Okay, so does everybody understand this basic example of factorial? Okay, 2 comments right here. Okay, does everybody understand? Did everybody take notes? Okay, that was a lot. Okay, very good, Carney. You took notes and you understand. Okay. Very good, Anthony. Then I will go to permutations. Okay, so permutation. You really need to understand factorial for this. So the definition of a permutation is an arrangement of a set of objects into a linear sequence. Okay, order does not matter. Please keep in mind that order does not matter. Does not matter. Okay, that is so wrong. How did I even prepare these? Okay, order does matter. Okay, that I was talking about combinations. Okay, big mess up right there. Okay, combinations order does not matter. Okay, permutations order is everything. Just, yes, don't pay attention to this knot right here. Yes, it does order. Order does matter. Okay, yes, just color that in. Yes, there we go. Okay, back to the topic. Permutations is an arrangement of a set of objects into a linear sequence. Order does matter, of course. It's an arrangement. Of course, order matters. Okay. If you have a set of objects, let's say A, B, and C. Okay, A, B, and C here. Okay, that's our set. Okay, that's our set. Okay, and we can arrange them. And let me give an example. This will be the example. An arrangement of ABC would be just ABC or ACB or BCA or something like that. You can list them all, but let me know. Let me tell you. Okay, you should know that this is not the most efficient way to do it. Okay, you can't just list all of them. Let's say you have a set of 1 through 100. Okay, you have 1 through 100 symbols. How are you going to list all of them? So this is where factorial comes in handy, okay? This is where factorial comes in handy. So basically, if you want to order all of these, it's just going to be 3 factorial. So that's how easy it is. 3 right here, or the n, is how many objects are in this set. How many objects in the set? We have the set A, B, C, right? How many objects are in this set? There are 3, right? So n is 3 factorial, okay? And if you actually list them out, a lot of you know that there will in fact be 6, right? There will be, in fact, be 6, right? Okay, so let's try another one. A, B, C, and D, okay? Can everybody tell me how many permutations of A, B, C, and D? Okay, how many permutations? Okay, Kaishi says 4 factorial. Very good, very good. 4 factorial, okay? And Carney says 24. Very good, you multiplied it out. Very good, so you understand, okay? It will be 4 factorial. So that is basically what a permutation is. Now let's go to combinations. Combinations, so combinations are just a tiny bit more complicated than my permutations explanation, okay? So basically, combinations, okay, are selections of items from a set of objects, okay, such that the order does not matter, okay? So you have a set right here. Let's do the same example, ABC again, okay? ABC. And combinations are basically selections of items within a selection of items. So it's like a subset, right? It's like a subset. So you have this set, right? And let's say you pick A and B, okay? So A and B are their own group within this whole set. You can also pick B and C. So how many subsets of two objects are in this whole set of three objects? That's a very basic combination question right there. Okay, maybe you'll see it on an exam test, but they usually don't give it out like that. They'll give it out as like a real world problem, and then you have to solve it. Okay, but let me explain. So you have, let's say, A, B, C, and D. Okay, so let me write out a question. How many groups of two can you form from this set? Okay, how many groups of two can you form from this set? A, B, C, and D. How many groups? Okay, so this is a very basic combination question. So let me explain this question first before I introduce the combination formula. So basically what you want to do is you have to pick out groups of two, right? You can pick A and B, okay? A and B. You can pick out like B and C, right? You can pick out B and C. You can also pick out like C and D, right? Or you can pick out B and D, okay? There are a lot of possibilities I'm going to tell you. And so one way we solve for this, okay? So Uh, this I'm going to introduce the combination formula for this. Okay, first. So basically, the combination formula is C is going to be the combination, of course. It's gonna be n factorial over k factorial over times n minus k factorial. That is the combination formula. Let me fix it. Okay. This is the combination formula, okay? This combination formula, okay? This combination formula, and I'm going to explain what everything means. So this n, right? This n, okay? Of course, I already explained. This is the everything in the set. Okay, this is the number of objects in the set. Okay, number of objects. Uh, number of objects. Okay, that will be n. Okay, so k is the number of objects in your group. Okay, so right here you want to form groups of two, right? So k would be 2 because that's the number of objects in the group you want to select, right? That's the number of objects in the group. Now, the number of objects in the whole set would be 4, right? So you can kind of just plug this in into this formula. And everybody, please take notes on this very formula right here because you might forget it. So this is very useful. Okay, so you just plug it in, but you have to find what n is first. So please make sure you do that first. So the number of objects in the whole set, that's going to be 4, right? A, B, C, and D. There's 4 objects. So 4 factorial over k factorial times n minus k factorial. Okay? So, what are the objects in the group you want to pick, right? That's 2, right? You want to form groups of 2. So k is going to be 2 factorial times 4 minus 2, right? N minus k, 4 minus 2 factorial, which equals 4 factorial over 2 factorial times 2 factorial, which is 24 over 4, which is 6. Okay? So now I'm going to explain why this formula works. Why does it work? Okay. But first, let me ask if there are any questions regarding this combinations explanation. Are there any questions, anyone? Is everybody taking notes? Okay. You understand, okay? So please confirm. No questions, right? No questions, Carney? Okay, yes, no questions. Anyone else? Okay. Does anybody else have any questions? Okay, Anthony, not done writing notes. Okay, so please keep writing notes for those who have not finished writing notes. Okay, I'll give you a few moments to finish. Okay, and please put in the chat when you're finished, and I can move on. Okay, not done yet. I'll give you a few more moments if you're not done yet. Does anybody else have any questions or is not done with notes? Please put it in the chat. Okay. Yeah. I keep saying the wrong words. Maybe talking too fast. So Anthony, are you done yet? Okay. Okay, done. Very good, very good. So now I will explain why this combination formula works. Now, permutations are kind of easy to understand, right? They're just arrangements, right? But combinations, it's hard. Like basically n factorial, it is the permutation, right? It's the permutation. But why? Okay. Why do we need to divide all these things? Maybe you understand the n factorial on the top, but why do we need to divide all these things? Okay. So basically, let me tell you, okay? So Anthony, anyone who is writing notes, this is also very important. Not just the formula, but we need to understand this formula, okay? We need to understand. So now I'm going to explain why this formula works. Now, n factorial is the permutation of all permutation. Okay. Permutation. Okay, that's a big word. So I'm just going to abbreviate it as P. Okay. So for those taking notes, that might also be a good option. Just abbreviate permutation as P. Okay, so the permutation of all objects. Okay, that is our n factorial on the top. Okay. So we have we're trying to select groups of 2, right? We're trying to select groups of 2. And that is what k factorial is. Okay, that's what k factorial is. So we select groups of 2, right? We're selecting groups of 2. So that is what k factorial. But why k factorial? K factorial, we can just divide k, right? No, that is not the case because here order does not matter. Order does not matter. Let's say you pick A and B. So AB is a group of 2, but AB is the same as BA, right? There's no point in calculating order because it's the exact same. BC is the same as CB. So that is why we divide this permutation of K, because the permutation of K is basically the arrangement of it. It's the order of it. But in combinations, order does not matter, so we subtract. I mean, divide this permutation, so we don't have this order. Okay, so this is the permutation. Let me abbreviate. Permutation of objects in group. Okay, and then n minus k factorial, it's the same idea. It's just, the other objects in the group. It's not just the very group that you're selecting, let's say AB, but we also have other objects like CD in our group. So we have to divide the permutation of those as well. Okay. So does everybody want to take notes on this? And I greatly recommend you to take notes on this. Okay. So is everybody done taking notes, or do you need a bit more time? Okay. So please put in the chat. Okay, Casey is done. Okay, Anthony, are you done? Carney, are you done? Okay. Also, if you have any questions on this content, please put it in the chat. Okay, Anthony is also done. Very good, very good. Okay. No questions? Then I will move on. This is quite difficult content to understand, and you guys are doing great. That's very good. Okay, so now I'm going to introduce the box method. Okay, so let me just raise a simple question. Okay, and I asked the same question, okay, in my last class with the 6th grade class, okay, when I was explaining the box method, because this is a very simple question, and we can use the box method to solve this. So now I'm going to explain this box method, but please put your answer. How many 3-digit numbers are there? Should be quite easy. It's 900, right? It's 900. 900 3-digit numbers. But how do you know that? It's just the matter of a matter of subtracting numbers, right? Okay, you just literally just subtract some numbers, count some numbers, and you get 900, right? You can count all the 3-digit numbers. It's common knowledge, right? Or you could go to Google and search it up. Though that is not recommended, especially when you're doing exam paper. Maybe teachers will catch you, and maybe you'll get caught by on cheating, and that's not good. So I do not recommend going to Google on an exam. And just yeah. But anyways, back to topic. Why do I always go off topic? Okay, back to topic. But we can solve this with a different method. We don't have to actually count all those 3-digit numbers. We don't. Okay, you don't actually count all these 3-digit numbers. Okay, so this is the box method, and this is very useful. So the box method, we're always multiplying. Okay, and this box method is extremely important. We'll use this a ton. Okay, so please write down notes on this. Okay, so you just multiply all these boxes together. Yes, and these boxes are okay. Okay, let me roll these first. So these boxes are all the possibilities for each of the digits. How many possible numbers are for the hundredths digit? How many possible numbers are for the tenths digit? How many possible numbers are from the ones digit? Okay, and we have 3 boxes, right? Because we have 3-digit numbers. We have 3-digit numbers. There's only going to be 3 digits. Okay, so how many numbers are possible for the hundredths digit, right? You can have 365. You can have 999, 110. Okay, those are all 3-digit numbers. But what we need is how many numbers are possible. Please, 0 through 9. 0 through 9 is 10 numbers, right? 10 numbers. Okay, 10 numbers, right? But can we use 0 as our hundreds digit? Absolutely not. If you use 0, it wouldn't be it really wouldn't be a 3-digit number, right? So subtract 0 from our list of possibilities. 1 through 9 is okay. So we have 9 possibilities right here. We have 9 possibilities. Okay. So next, we have our tens. Okay. We have our tens digit. Now all the numbers, right, 0 through 9 are all possible, right? You can have 900. You can have 990. Okay. So 10 numbers available. And for the ones digit, the same. 10 numbers. Multiply that. 900, right? 900. Okay, we get 900. So does everybody understand this box method right here? Okay. See. Okay, no, we didn't actually learn permutations and combinations a few months ago. That was my last class, okay? Once I'm done with this introduction, okay, we'll do much harder, okay? Examples, okay? That was the permutations and combinations you learned was probably from my last class, 5th and 6th grade class, and those were quite easy, so don't bother with those. You should already know them. But okay, after actually, are there any questions on this box method yet? Okay. So no questions, right? No questions. Carney, no questions. Anyone? No questions? Then I'll move on. So now let's do some practice problems. Okay, first one should be very easy. I just asked this one. How many permutations are there of A, B, and C and D? A, B, C, and D. How many permutations? 4 factorial, right? 4 factorial. 24, okay? Next. So this is our combinations, okay? Combinations, please use your formula, okay? So number 2, there are 6 students and they're asked to form groups of 2, right? Form groups of 2. How many groups of 2 are possible, okay? Very standard combination problem. Probably see it in an exam or something, okay? So please put it in the chat box. 3 groups. Okay, Anthony says 3 groups. Are there any more answers? 3 groups. Okay. Does anybody have any more answers? Okay, you don't know how to work out the formula. Michael says 60. Okay, very good. 60 and 3. It's quite the diversity of answers. Okay. Any more? Carney, or Kaisi, are there any more answers? Okay. If you understand, please give me some answers. Okay, no more answers? No more answers? Then I'll walk you through it. And by the way, Michael, your answer is correct. Okay, and I just did that mentally. Okay. There are 6 students and they're asked to form groups of 2, right? what is our combination formula again? N factorial over k factorial times n minus k factorial, right? Just substitute it in, right? N factorial, how many objects are in our set? Right now we are given 6 students in total, right? So that is our set. We have 6 students in our set, 6 factorial, over how many, what is the number of students we want in our group? We want groups of 2, right? Groups of 2, so 2 factorial, k equals 2. And then n minus k should be quite easy. What is n? 6. What is k? 2. N minus k, 3. 3 factorial, okay? And now 6 factorial over 2 factorial times 3 factorial, 720 over 2 times 6, 12. Okay, so 2 factorial is 2 and 3 factorial is 6. 6 factorial is 720. If you don't trust me, you can do it on your calculator. Okay. But if you preferred, if you actually memorize these factorials, it'd be very handy. Okay. And from this, you can see that that equals 60. Very good, Michael. And Anthony, do you understand how to do it now? Okay, yes, very good. In my profile picture, you mean this red wolf, right? Do you mean this red wolf? This one. Oh, you just go on Google and search up that one, red wolf. Uh, well, actually, you have to search like red wolf cartoon and it'll show up. So number 3. And last time, last 2 problems we just did permutation and combination problems, right? Okay. And number 3 is going to be using the box method. Okay. So David's tablet has a 6-digit pin. Okay, that's very normal. But each number can only be used once. Only used once. Can't use it over and over again. That's a very weird pen, though. It's probably not going to happen on a real iPad, but for the sake of the question, let's do that. So how many pins are possible if each number can only be used once? Okay, pay attention, only be used once. So let's say you have 10 numbers for the first digit. The second digit you have 9 because you're going to assume that one digit is gone. You use that one digit. So the second digit only be 9, right? So okay, so please multiply that out and give me your answer in the chat box. So I'll need to go to the restroom for a minute, but I'll be back real quick. And please start working. Okay, I'll give you a few moments. Okay, I'm back. 10 comments already. Okay. So very good, Carney. You remember that from previous lessons? Anthony, you don't know? Then I'll give you the answer. Give you the answer. So, David's tablet has a 6-digit pin. Okay, use the box method. Okay, so we have 6 digits, right? We have 6 boxes. 6 boxes. So here we have 6 digits, 6 boxes. Each number can only be used once. For the first digit, we have 10 numbers. 10 numbers, right? 0 through 9. Second number, we have 9, right? 8, 7, 6. Now why? This is because every number can only be used once. So let's assume you get a 5 on the first digit. Your first number is a 5. Then we can't use 5 again, right? We can't use 5 again. So that is why our choices for our second digit is lowered to 9, right? So we just go down by 1 every digit. 10, 9, 8, 7, 6, 5. So this is also a pretty standard box method problem, okay? So we just multiply out, okay? And for those who got like, if you actually try to solve and your answer ends with like, you somehow get like 8, 9, 6, 5, 9, that is completely wrong. Why? Because you have a 10, right? It's going to end in a 0. That is just common sense right there. So you also have to make sure your answer is reasonable when you are multiplying. Okay, so 10 times 9 times 8 times 7 times 6 times 5. That would be 151,200. So please verify. Okay, let me multiply again to make sure I didn't make any mistakes. And this is also a very good habit. Make sure you don't make any mistakes or punch in a wrong number in your calculator. So, basically now I'm going to go over counting methods. So, okay, I'm gonna go over some counting methods. So, does anybody have any questions for the previous problems? Are there any questions? No questions? Then I will begin. So first, I call this the exclusion method, okay? The exclusion method. So the exclusion method is basically all outcomes minus uh, unwanted outcomes. Okay? Unwanted outcomes, right? So that is method 1, the exclusion method. If you subtract all these unwanted outcomes from all the outcomes, then you get the wanted outcomes, right? So let's say, so how many 3-digit numbers are multiples of 5? Okay, that is very basic question, okay? Very basic. So what are all the outcomes? We have 900 3-digit numbers, right? Those are all the outcomes. We have 900 numbers, 3-digit ones, okay? And then subtract the ones, okay? So let's keep in mind, how can a 3-digit number be multiple of a 5? Okay, so we can use the box method. How many 3-digit numbers? 9 times 10 times 10, right? But that only works for the first two boxes because our last digit matters the most. For a number to be, okay, a multiple of 5, it has to end in 0 or 5. So we only have 2, okay? We only have 2, okay, possibilities for our last digit. And what are the unwanted outcomes? That'd be 9 times 10 times 8, right? Okay. Because our wanted outcomes is going to be 9 times 10 times 2, okay? Those two possibilities are 0 or 5, okay? And we don't want those possibilities. We just don't want them. So we're going to choose every other number, okay? Our last, okay, digit, then it will not be a multiple of 5. To subtract this, okay, you will get 180, okay? Okay, so, but that is the exclusion method, right? All outcomes minus unwanted outcomes. Method 2, okay, let's go over method 2. Method 2 is just case by case. So case by case is basically just trying to find all the possibilities. If you use the same, let's use the same problem, right? Case by case, if you want to solve it, it's just going to be 9 times 10 times 2. Get 180 right off the bat. And you can see that case by case is much more effective for this problem, okay? So case by case, you can just solve for the actual possibilities, the wanted outcomes. But if these wanted outcomes are like too great, okay, you have 2 or 3 or 4 possible outcomes, okay? You have a lot of possible outcomes, then you might want to use exclusion method because it will be much more efficient. But in this case, we only need, okay, we only have 2, okay? We only have 1 outcome, okay? That these 3-digit numbers are multiples of 5, okay? So that is case by case. So, are there any questions? Any questions? Are there any questions? Okay, Carney, Kaishi, okay, Anthony, are there any questions? No questions. Very good. So, let me go to some practice problems. This is the last section. Okay, and those are, we only have 2 practice problems, but these are pretty hard. Okay, these are pretty hard. So, our first question, okay. Consider all positive 3-digit numbers with distinct digits. How many are greater than 700? How many are greater than 700? Okay, so please put this, okay, please put your answer in your chat box. Okay, so I'll give you a few moments. Consider all positive 3-digit numbers with distinct digits. And distinct digits means every digit is not the same. Remember that 6-digit pin, right? The 6-digit pin, you cannot use the same digit over and over again. Once you use it, it's gone. Throw it out the window. It's gone. Okay? So distinct digit. Every digit is not the same. Okay? So I'll give you a few moments to try and solve this one. Okay, so few moments, and put your answer in the chat box. Okay, Anthony, what are you raising your hand or put your question in the chat. Okay, and also I'm waiting for answers. Okay, are there any answers yet? Are there any answers? No answers. Okay. I will walk you through it then. Okay, Carney, go back. So I'll give you a few more minutes. Okay, Anthony says 199. Very close, but it is not correct. Very close though. 200. 200 numbers greater than 700. Please keep in mind that each digit has to be different, okay? Each digit has to be different. Let's say you have 900, okay? Yes, that is greater than 700, but two digits are the same, okay? Please keep in mind that 200, okay, I mean 900, 0 and 0, those are the same. You can't work. Okay, Michael says 299. That also is too much, okay? Too much. Let's say you have 999. That is greater than 700, right? And it's the biggest three-digit number. Okay, that does not work. Why? Because 999, each digit has to be different, right? That's not going to work. So let me walk you through this one. Use the box method on this one. Okay, so how many numbers can be the first digit? Okay, the hundredths digit. Hundredths digit. If you want it to be greater than 700, of course it has to be the hundredths. Of course it has to be 7, 8, or 9, right? You have 3 possibilities. What about the tens digit? We're supposed to have 10 possibilities, but that's incorrect. Why? Each digit has to be different, right? Each digit has to be different. That's why we're going to subtract one number from 10, because we assume that we already used that number. Okay, so it's going to be 9. Next, we still have 10 possibilities for 1, right? Absolutely not, because we already used 2 numbers. We can't use them again. Distinct digits, right? So it's going to be 8. Okay, multiply these together. It's going to be 216. Okay, 216. So does everybody understand now? Okay. No questions? Then I'll move on to our last problem. Okay, very good. You get the question, Anthony. What's my email? Uh, okay, I'm not going to tell you that. What's my email? Uh, but okay. This is the second question, anyways. In how many four-digit integers is zero either the tens digit, the units digit, or both? And how many four-digit integers? Zero, either the tens digit, the units digit, or both. So, okay, we have and basically I'm just gonna walk you through this one because this one is pretty hard. You have to use the exclusion method to solve this one. So okay, we have a few possibilities. Okay, this is our four-digit numbers. We don't care what the first two digits are. Just know that zero can either be the tens digit. Okay, it can be the units digit. Okay, or it can be both. It can be both, right? One way to solve this is to use a union. A union B. Okay, but that's not gonna happen because I haven't explained unions yet. And unions are a bit hard to understand. So first I'm just going to teach you how to do this with the exclusion method. So the exclusion method. So basically exclusion method is all the possible outcomes minus the unwanted outcome, right? So let's do this. Okay. So what are all the possible outcomes? All the possible outcomes. Let's see how many four-digit integers are there. There's 9,000, right? There are 9,000 four-digit integers. Minus the unwanted outcomes. What are the unwanted outcomes? Okay, well, think. We have a four-digit number. Usually, to get all the four-digit numbers, it's be 9, 10, 10, 10, right? Okay? So, but then, uh, if you want to have a zero right here, it's only going to be one possibility, right? Because we know zero is going to be in the tens digit, or we know it's going to be in the units digit. So basically, the unwanted outcomes are where there are no zero, because usually we have two tens as possibilities, but right now we don't have a zero in our arsenal of numbers. So we just subtract the zero, throw it out the window, and we are left with 9 outcomes. Every number, 0 through 9, except for 0. Subtract this, 9 times 10 times 9 times 9, which will be 7,290, equals 1,710. Okay? So that is the answer. Does everybody understand how I use the exclusion method for this one? Yes, Anthony. Why are you raising your hand? Okay, so how do I draw? I use a Samsung pen. Okay, I'm on a Samsung tablet, and I use a special pen that comes along with the tablet. Okay, and basically, you see here, I'm on a PDF. So this is basically a write on PDF, and so basically, it's like an Apple pen. iPads have this feature as well. Okay, and Does everybody get this question anyways? Does everybody get this question? Does everybody get this question? Okay. Are there any questions about this question? Okay, yes, you get this question, right? Okay. Very good. Carney. Okay, Carney, are you still here? Carney, do you get this question? Anthony, do you get this question? Oh, now you're back. Oh, so Carney, did you hear this second question over here? If not, I'll explain it again. Did you hear this question? The second practice problem that we did. Nope. Then I'll explain it. So basically, the second practice problem is how many four-digit integers is zero, either the tens digit, the units digit, or both. So we have three possibilities. Okay, right here. So we have our four-digit integers, where zero is the tens digit. That's the first outcome. Second outcome, zero is units digit. Third outcome is both. Okay. So we use the exclusion method. So what are the unwanted outcomes? Okay, it's going to be all the four-digit numbers except it's the last two, the tens digit and the units digit. Okay, they're going to mean 9, right? Because we were supposed to have 10. We're supposed to have 10 possibilities, right? But we don't want our 0. Okay, we don't want that 0. So we just remove that from the list, and we can get 9, right? And then we subtract these unwanted outcomes, and then we get the wanted outcomes, right? So this is our answer, 1710. So, and thank you for listening, everybody. Okay, if you enjoy this class, please come to the next one. It will also be on counting techniques. So thank you, everyone, for coming to this class.